Hey guys, Mr. Skelton back at it here for lesson 5 of unit 4, and today we're going to be talking about an acronym which is Cpctc, and we're going to learn about that. And basically this is an extension of the shortcuts that we've learned. Again, I'm going to have you write them down. We'll just list them here. 1, 2, 3, and 4. What are the 4 shortcuts or triangle congruent statements that we've learned? SSS, side, 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 angle, side, whoa, I'll just go angle, angle, side, and then angle, side, angle. Okay? And we've also learned the 5th, which is AL. Okay? And I kind of made that squiggly line there because HL doesn't have 3 there. That's the hypotenuse leg. And so what we're going to do today is use Cpctc, and Cpctc is used after you prove the triangle's congruent, in a nutshell. All right, let's jump right into it. So it says, recall, how many congruent parts do we need to prove triangles are congruent? Well, we only need 3, right? Side, 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 angle, side. All these have 3. HL technically has 3 too because you have a right triangle, hypotenuse, and a leg, so there's still 3 there. How many parts are congruent in congruent triangles? There's actually 6, right? There's 3 angles and 3 sides. Okay? So it says, therefore, if we can prove that 2 triangles are congruent with only 3 parts, and there are a total of 6 parts, then that means the remaining 3, 6 minus 3, are also congruent by the definition of congruent triangles. Okay? So it says number 3 above is the idea behind Cpctc. Now here's what Cpctc stands for. I'm going to get my highlighter here. Move this up just a touch. CPC stands for corresponding parts of congruent triangles are congruent. C, P, C, D, C. Okay? And here's basically how we're going to use this. It says Cpctc, if 2 triangles are congruent, that's the big. If the triangles are already congruent, so you've already used SSS or SAS or angle side angle, then all of their corresponding parts are also congruent. That should make sense to you. Don't overthink this. Think about it this way. These 2 triangles, look at them. Okay? Why is triangle KLJ congruent to OMN? Side, angle, side, SAS. Since the triangles are already congruent, aren't all the pieces of the triangles also congruent? Obviously, yes, that is true, right? If these 2 are congruent, then everything about them is congruent, right? This angle would be equal to this angle over, let's see, if I said this angle, then it'd be this angle, and this angle, this side with this side. So therefore, JK is equal to NO because of Cpctc. Okay? So let's take a closer look at a problem here. Power surge. Awesome, thanks. Okay. Oops. There we go. So how are you, I guess for me, well, let's finish this up and then I'll kind of talk and give you a helpful hint. Big idea. Cpctc is only used when or after you have proved 2 triangles are congruent. So you're not going to do anything different than what you have been doing with proofs. All you're going to do is add an extra step. Cpctc comes at the end and will always be your last reason. Now, the first question I always get is, Mr. Skelton, how do you know when to use Cpctc? And you'll know right away, right here by the proof statement. Okay? Now look at this proof statement. How is it different than what you've done in the past? Well, most proof statements say prove triangle blah 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 is congruent to triangle blah blah blah. Right? And that's when you use SSS, SAS, etc. What are they asking you to prove? They're not asking you to prove that 2 triangles congruent. They're asking you to prove 2 parts congruent. Anytime you see 2 parts congruent, whether it's a side equaling a side or an angle equaling an angle, you know you're going to use Cpctc. It's a dead giveaway. Okay, so let's take a look at this proof right here. Let's see, statements. AB is congruent to EB. That's given to us with the markings. Okay. What else is given to us with markings? Looks like angle C is congruent to angle D, given. I like to put markings down there because it's in my markings. Okay, reason 3 is given to us, vertical angles. So where are vertical angles? We should be training our brain to see those. Now we can't just say angle B equals angle B, right? Because there's 4 angle B's. We got to name it correctly. So I'm going to say angle CBA. If I say CBA, I started with C, which has this one swoop mark, so I got to start at D, which has a swoop mark. So angle DBE, vertical angle theorem. Okay. Now, it says triangle CAB is congruent to triangle DEB. Why are these two triangles congruent to each other? Angle, angle, side. Angle, angle, side. And then we have now shown that the two triangles are congruent. These two triangles are equal to each other. That means everything about them, all 6 angles and all 6 sides, are congruent to one another. And specifically speaking, AC equal to ED because of Cpctc. And that's all you do. Okay? Let's go to the back. So now we just have some more proofs, so we're just going to try to knock these out here one at a time for you. And hopefully keep giving you some confidence with some proofs. Okay? So the first thing I'm looking at is I see this. What does that tell you? Oh, that shows an angle equal to an angle, or a part equal to a part. I know I'm using Cpctc for a fact. Okay? All right, we got some tick marks here. I'm going to say MO is congruent. If I say MO, I'm going to say, let's see, RE. And that's given to us, markings. I also have another 2 tick marks here. I'm going to say ME is congruent to, if I say ME, I got to say RO, right? Because these are going to flip over each other. So that's given, markings. All right, what do you notice? Hopefully you notice the reflexive property. Now I know some students, and on this problem, because the triangles will flip over, you could put OE equal to EO, but most of the time we just keep it the same, right? That helps with reflexive. Okay. Do you have enough information to show that the two triangles are congruent? I believe I do. There's a side equal to a side equal to a side, and a side equal to a side, and then just look at your picture. Remember, you should always be drawing the diagram and always marking your picture. So I have triangle, I'll call it whatever I want to call it, OME. OME is congruent to, if I said OME, I have to go, let's see, O, M, and E, so I got to go over the tick mark and then over the second tick mark, so I got to go ERO, ERO, and that is side, side, side. So I've just proved that these two are congruent, which means everything about them, all 3 sides of this triangle and all 3 angles of this triangle are congruent to all 3 angles and sides from this. So I can say now angle M is therefore congruent to angle R because of Cpctc. Boom. Done. Okay. Let's see. This one says the proofs are going to be a little bit tougher. So let's just see what we can do here, which is good. So this is a situation that's just a little unique. So let's take a look at it. It says JM is congruent to LK. All right, that looks like it's given. Markings. JK is congruent to LM. It's also given to us. All right. MK is equal to KM, so this is works out kind of neat because up here I told you, you didn't have to switch them, but technically we could have called it EO. This one, because it's almost the same picture, right? We would flip-flop it, so this would be still the reflexive property. And I'm going to mark that 1, 2, 3. Why are these triangles congruent? They're congruent by side, side, side. Okay. Now look what they're asking you to prove here. They're asking you to prove that 2 lines or segments are parallel. What have we done in the past? What have I asked you to use to prove that two lines are parallel? You should be thinking the converse of either SSI or CA or AIA, right? That's how we prove lines parallel. That's why this one's a little tough. Okay, let's take a look here. Now I bolded this for you. Why is angle JKM, which is here, JKM, let's mark it, congruent to LMK? Let's mark that. Well, those are congruent because the two triangles are congruent by SSS, so all angles have to be congruent to each other from Cpctc. Now look, why is ML, which is right here, parallel now? Have we proved that? We have, because of the converse of, look at these angles. Doesn't that look like this? There's your lines. There's your transversal. And you have this angle here and this angle here. What type of angles are those? Converse of AIA. Boom. Good proof there. Tough one. Okay. At the bottom there I said notice CPC always comes as the last, does Cpctc always come as the last step in a proof? Technically not. Does Cpctc directly prove lines are parallel? Yes, okay, because once you have angles equal to each other, I understand how you can say yes and no, but for this situation, does it prove directly that lines are parallel? I'll say yes because of the picture or the diagram that's given, but depending on the diagram, you could answer that no as well. I'm kind of answering it to this question right here, okay? All right, let's take a look at the last one. Oops. So number 2, to prove a segment is an angle bisector, okay? So what we're going to do here is it says given P is the midpoint of IO. So I'm going to put P is the midpoint of IO, and that's given. All right, number 2, I have some markings. I have IS is congruent to OS, and that's given because of the markings. Okay. Now, what does P being in the middle of IO mean? That means this, right? So I'm going to say IP is congruent to OP. Now, what's the reason? Why did I put these markings here? I put these markings here because it told me P is the midpoint. So why did these markings happen? Why are these congruent? Definition of a midpoint. Okay, number 4, I see that they share SP, so I'm going to put SP is congruent to SP. So that's going to be the reflexive property. Okay. Okay, I know that these two triangles are congruent, so triangle ISP is congruent to triangle OSP from side, side, side. Now, look what it's asking you to prove here. It's not asking you to prove two parts, okay? It's asking you to prove that PS bisects ISO. All right, so what would we need to show in our statements to prove that PS is an angle bisector? Well, in my mind, I'm thinking, okay, here's PS. I want to prove that it bisects ISO. Well, what do you know about this angle and this angle now that you know that these two triangles are congruent? If these two triangles are congruent by SSS, don't these two angles have to be congruent by Cpctc? You should be shaking your head yes. That makes sense, right? So angle ISP is congruent to angle OSP, Cpctc. Okay? And 7 says PS, I've just proven that PS bisects angle IOS, right? And I'm going to say let's see, definition of, definition of a angle bisector. Okay. Because I was able to use Cpctc, I was now able to prove, okay, that PS is congruent to, or the angles are congruent, therefore PS has to be an angle bisector. And number 3, to prove, let's see, can you, yep, still in the picture, to prove a point is the midpoint of a segment. Number 3. We would do the same thing, okay? You would just add in some extra steps there. Don't really worry about number 3 here right now, but it's basically saying, you know, the same situation as proving that PS bisects iOS. I could say, you know, instead of prove this, I could just say prove, you know, P is the midpoint of a segment. It'd be the same thing, okay? Finishing up here, these are not the only other things Cpctc can prove, but these are the most common ones you'll see in the unit, okay? Proving that something is a midpoint of a segment, or that you have an angle bisector. But again, it's a lot of using Cpctc. We know those are congruent, and so that PS has to bisect. PS is technically an angle bisector. Okay? Hope that was helpful. Hope you're getting better at proofs, and we'll check back with you on the next video.